my topic, as Yanis introduced, is going to about use of digital twins for buildings. And subtitle, which is larger, is digital twin is the answer. What was the question? So I'd like to stress the importance of having a good purpose of a digital twin. That's going to be the theme of my talk. And it's, as some of you might know, it's a paraphrase of technology is the answer. What was the question by Cedric Price, a British architect. I think he said it about like in the 1960s or something. So I was asked to structure my presentation. Another guideline that I was received was to structure my presentation focusing on the 4 questions. So I am going to do so, and I realize that it's going to be a unique way of presenting a talk, presenting my thoughts. So the first and the second one, we talked a lot about the first and second one, so I'm going to skip through it very quickly. So there are 2 things that we can think about when we talk about digital twin technologies. We can talk about general purpose technologies to acquire and visualize information, and specific use cases and the technologies to support those. We talked a lot about these technologies yesterday, and I realized that so you are now familiar with the term scan to beam. So scan to beam, I think most of you know this term, but scan to beam is different from plain 3D scanning because it requires another step, additional step to convert surface models or solid model into object-based model. So if there is something like that, then that doesn't have any meaning. So somebody needs to add semantics to it to say that that is a column. So that's the difference between 3D scanning and scan to beam. And it's called, the process is called semantic enrichment. And for the specific use cases and supporting technologies, of course, user can use any type of technologies to input information through mobile phone or through the internet. And we can connect a digital twin to existing databases. We can create our own database specific to our goals. We can gather data from sensors. We talked a lot about this. There are lightweight technologies, 3D scanning technologies and some other technologies that regular users can use these days. Of course, these technologies do not give you accurate or very scalable data, but still it's very user-friendly. One example is AR Core, which used to be known as Tango Project, Google Tango Project, and also iOS has something called AR Kit. It's usually for augmented reality, but it was initially developed for indoor navigation SLAM. But now it's being used for games and so on. There are challenges. It is still challenging to represent geometric data in a lightweight, scalable, stable, exchangeable, and operation system independent way. So that's one of the goals that we need to achieve if you want to develop a digital twin that can support various scenarios. Another challenge is how to fill in unavailable or inaccessible information. Of course, in terms of geometry, visual obstructions and occlusions, in terms of 3D scanning, are challenging, but I mean, in addition to those, there are certain information that we cannot easily get, or some information that's not available to us. So how can you fill those gaps in? How can you assure information quality? That's another thing. We can do it manually. Currently, many database systems already has some type of rule-based quality assurance mechanisms built in it. For example, if there is a building and if we type mistakenly like 3 meters as the height of a building, then system will let you know that you made a mistake. Or if you type in email address in a wrong way or in a grammatically wrong way, then it'll let you know. There are studies to use deep learning algorithms to detect, for example, if you model something, then let's say that you are going to model a column, then you need to use column object to model a column in a BIM model. But if you use, some people use like wall, or because the column has a flat shape, it's easier to make column with a flat shape using a wall. So people create a column using a wall object, and that creates a lot of problems if you try to use the BIM model for different purposes. So there have been a study to use deep learning to automatically detect those anomalies. Of course, we need to think hard about information visualization. We are going to get a lot of complex information and simulation results. What's the best way to visualize this? I really love the presentations from Siemens, because the slides presented complex ideas in a very beautiful and understandable way. So we need to have something like those for complex and complex simulation results. Semantic enrichment. I briefly talked about semantic enrichment. We can use these three methods again. Raphael and Yanis and many scholars are working hard on these areas. I'm also interested in this area a lot. How to keep a data twin up to date is also a challenge. We have a different section which talks about this. I'm going to save it for the future. Are we ready for the digital twin era? This is a study done based on biannual surveys. I've conducted a survey every 2 years and conducted many case studies, and learned that there were several steps of BIM adoption. And now we are in the Lean BIM era. So by Lean BIM, we are trying to convert our industry into more manufacturing-oriented industry. So think about modular construction, the Catera syndrome, or Catera popularity of the Catera, the company, and also think about the multi-trade modular prefabrication methods and so on, adoption of lean concept for managing BIM projects, construction projects. Those are all Lean BIM thing. I predicted that AI BIM using digital twin, connected BIM, smart cities will come or will be a common practice. Not now. We can do things about digital twin. We can read digital twin and smart cities, but I don't think it will be a common practice very soon. But will be, if we do it right, it will be a common practice in 10 years. The reason I said it is because I don't think that our industry has big data. We talked a lot about the temperature data. Temperature data, weather data is easy to get, relatively easy to get. Traffic data, okay, we can get it. But what about construction? For example, photos. Can you get construction photos easily? There are a lot of pictures, and I took a lot of pictures when I worked for a construction company. A couple of years ago, I took a lot of pictures when I worked for a construction company, but I didn't have time to organize the pictures. So I came up with an idea of using deep learning to automatically categorize the photos by job type. I thought that should be straightforward. It wasn't, first of all. I collected over 20,000 pictures, construction photos, from 47 construction projects. After filtering out all the photos that are not directly relevant to job type, I ended up with around 1,500 pictures. Think about panoramic view pictures. Can you tell job type? No. Think about a picture of a hammer or special equipment. Can you talk about job type? No. Think about a worker, a picture of a worker. That's not a job type photo. So only like 7% of pictures could be used to get the pictures or information that you'd like to use, you need a lot more information. And out of that, you can you can utilize a tiny bit of it for your purpose. So we need a lot of this kind of thing. And as Jakob proposed yesterday, we need a big database where we can share these type of things. I talked only about the construction photos. Probably we need to have something like ImageNet for construction photos. So one of the most advanced deep learning algorithm website or machines for image recognition is Clarify. If you go to clarify.com, if you upload your picture, it will immediately say guy smiling, person smiling, and so on. But if you upload any construction photo to that, it won't recognize anything because it's not trained for construction job at all. So to do so, we need some time to collect these, and I think we will be able to have something like that in 10 years, hopefully. Detailed twin itself, we had a discussion among the blue team about this, and I actually presented it to the blue team members. But there are three terms that are used interchangeably: detailed markup, beam model, and detailed twin. I also use these terms interchangeably. Let's take a look at what these terms are. And I observed how people use it, if they use it in a distinctive way. So when they talk about detailed markup, this is, by the way, a picture from Simmons' website of detailed markup. They say 3D detailed model, which may be directly editable or sometimes not, and usually without property information. And it usually focuses on a specific part of a big, larger facility. Sometimes it has a visualization function like this. Initially, when there was a detailed markup functions embedded in a mechanical parametric systems such as CATIA, they used to have, they still have simulation functions, but when you talk about detailed markup, we don't really expect visual simulation. In architecture, for buildings, when you say detailed markup, we mean a partial model with high level of detail for design review or constructability review. That's how we use the term. BIM model, it can be texture, 2D, 3D. It can be directly editable. It has a lot of rich property information. It must have some, but in terms of the target, it's usually individual facility or small setup facilities. In terms of visualization, we don't expect strong visual simulation. We don't expect it from BIM, although it can have weak or medium level visual simulation. However, on the other hand, detailed twin, when we say detailed twin, we expect a strong level of visual simulation, right? And also we think about a larger scale facility, like a city. It's usually not directly editable, except for those, the concept of detailed twin is similar to BIM model, so we often use detailed twin and the term BIM model interchangeably. This is how I think the structure of detailed twin should be. There can be a detailed twin platform. Of course, the detailed twin platform should be lightweight, fast, reliable visualizer with the database behind, and also it needs to have a strong support for standard. So you can add smaller detailed models, twin models on the system, directly on the system, or you can import detailed twin models into your system, into the platform, so that they look like a single system. And to get the information, I don't believe that we need to get all the information in one system. Probably there can be software vendor or the cloud database provider which can host all of this, but conceptually I think the source of information should be separated. So traffic database should remain as a traffic database, but it can be connected to a digital twin platform. Multiple construction databases can be connected to a digital twin platform to provide pre-processed data or processed data. Point cloud, I talked about point cloud yesterday, so we don't need to host point cloud data as it is on a digital platform. It should be pre-processed into a building like this. Then it can also have information visualization and simulation layers added to it. To make it happen, as Barry explained, we need a standard way of mapping things to each other. By standard, I don't necessarily mean IFC or ISO standards. It can be standards among, at least among these guys, this group, who would like to share that. If we'd like to expand the functionality of digital twin, of course, we need to have standard with the higher authority, such as ISO standard. Then we can link different digital twin platforms and let them talk to each other. There are two, Jakob introduced many standards that are related to this, and I'd like you to pay attention to these two specific standards. One is ISO 23247, is Digital Twin Manufacturing Framework. This is in the early stage, it's in the committee draft stage, but if you're interested in it, you may keep track on this effort. Another one is the Information Delivery Manual. It's already a standard 29481. Dash 1 is the main one, dash 2 is the supplementary one. And it defines the use cases and the information required by the use cases. The EIR or ER is the information requirements. So by having this, having more and more of this, you can allow systems to import and export through the schema that you define according to specific use cases. There are some other standards that are directly related to it. From the digital twin to the real world and back, this is the update issue. So I kind of paraphrase this question to who should update the geometric and non-geometric information of a digital model or digital twin model, and how. For the lightweight update, I think it should be done by regular users of a system. So by regular users, I mean engineers, designers, facility managers. We can do a crowdsourcing, or we can use sensors. Of course, heavyweight update, in terms of complexity, accuracy, and scope, we need a professional digital twin manager or engineers. There can be many ways to do it. I think we need to have a simple BIM editor. We don't need a full-scale BIM authoring tool to update a model. This is kind of one area that we can take a look. For example, let's say that there is a facility manager, and we know that or asset manager, there is a space which was a large space but divided into several rooms. To update this model, should we go to a special digital twin manager to update it? No. We should allow a facility manager to draw certain lines or wall in a model to update the thing. So that's kind of a scenario, and that's what I meant by a simple BIM editor. And by lightweight scan to BIM, I mean the mobile-based 3D scanner, which will be available soon, I think, to the public. And if I need to scan this room, probably I can do this and then send it to the digital twin platform, and digital twin platform will receive pre-processed data or surface model out of that to update your model, digital twin model. I made many mistakes before and during my academic career. And one system I worked for, as I mentioned several times, I worked for a construction company for about 6 years before I pursued my PhD. And while I was there, I worked on several things, and one of my role was to develop a system for the construction company. So I developed a system which allows the field engineers to report defects on site. I thought if we have the system and if we know how they fix the problems, we can kind of develop a knowledge-based system. It was like mid-1990s. And what happened was the system failed. Nobody wanted to input the data. The reason is because if you report about any defects they made, then it's like saying that I made these mistakes. So nobody wants, no field engineers want to report the defect. They do it on paper and so on. About the same time, there was a another contractor, who developed a similar system, defect report system. But it was very successful. The reason was because they asked future residents to come to the site and examine their future home. So they made a very detailed report to the system, and the field engineers had to report what they did, how they fixed the problem in detail. So it kind of worked very well. So I call it a perpetual motion mechanism of an information system. So first, there should not be any redundant data input, and also it should align with daily routine. So it should be a part of your job. You need to input it to, for example, get paid or something, or to get approved for the day. And also, you need to think hard about who should be the person to input the data. And the person should have immediate benefit. Otherwise, they won't input the data. So this is kind of my approach to develop any system, but I think this also applies to the mechanism to update detailed twin data. And another thing that we can think about is information patching. It's a concept that Chuck Eastman proposed in the late 1990s. So we are going to have several federated databases, and how should we propagate the changes throughout the different federated databases? So this is similar to the issue that Brett raised in her presentation. Tech transfer and market penetration. I think the keyword is market penetration. In Korea, smart city is a big thing, and the digital twin, the interest in digital twin grew along the interest in smart cities. Now we have 2 official smart city projects, but 67 cities claim that they're going to be a smart city very soon, in 5 years. So if you look at the magnitude of growth of interest, if you look at the government funding, compare the government funding, analyze the government funding for the past 10 years. In 2005, the funding for digital twin, research funding for digital twin was only $255 US. In this year, 2019, the research funding for digital twins is $130 million. So the growth rate is 500 times. In terms of number of projects, the number of digital twin research projects reached 100 this year. So we do have a lot of interest in this. This was one of the questions: what level of maturity should digital twin tech achieve in order to attract the target industries? This was one of the questions given by the organizers. I think what is important is, as many people said, to know the purpose of the digital twin system. And what we should identify, I think we have enough technologies or enough technologies that are mature to support our needs. But what we need to focus is most viable product. What are the small things that we can solve right away? But some of them are not really interesting. It's like, so here's another failed story. I made many mistakes, and this is just a few of them. And this is a system that I developed about 10 years ago. My engineering building is notorious for being very complex. So people often get disoriented in the building because it has many turns and is connected to 4 large engineering buildings. So I thought that we can use our indoor navigation technology to find the way-finding thing. And so we use a Wi-Fi fingerprint-based indoor navigation system and develop a mobile-based fire evacuation system. It worked well. We spent like 3 years to develop this system, although it looks rudimentary because it was developed internally. But I got several feedbacks like, what if a guy in a fire situation did not have the app? Can he download it? Or what if your building has not been scanned into the system? So I was in trouble, so I developed something else, which is called IoT-based smart exercise system. So the exercise usually has a fixed pictogram like that. But what if there is a fire in that direction, towards that direction? We will die. So what I made is IoT-based system that can automatically change the direction based on the fire detection sensor. So we can probably use this much better in the system. So this is it for my presentation. I'll skip the summary because I am already late by 1 minute. So thank you very much.